Good morning, everyone. Myself is Moin Akhtar. I'm a physics lecturer in National Bio Science and Commerce College, Baswanagar, Hubballi. So today I'm going to teach you how to find the refractive index of a glass by using glass slab and traveling microscope. So this is our today's experiment. So in this experiment, we are finding refractive index of a glass by using glass slab and traveling microscope. Okay. As already I have mentioned, so today we are performing experiment, that is 14th experiment of second PUC, that is the refractive index of a glass. So here the aim of the experiment is to determine the refractive index of a glass using a glass slab and traveling microscope. So this is a glass slab. So as in theory classes we have studied about refraction of light. So to study the refraction phenomena we are using a glass slab. So this is a glass slab. So this we have to use. And this is a traveling microscope. This is a traveling microscope. So we will use this to find the refractive index of glass. Next level. See, on which principle we have to perform this experiment? Refractive index of a glass with respect to air is the ratio of real depth and apparent depth. In theory classes we have studied about real depth and apparent depth. So refractive index is the ratio of real depth and apparent depth. So on this principle we have to perform this experiment. Then, so which formula we are going to use in this experiment? So to find the refractive index of glass, see, they have given the formula. Ng is equal to R3 minus R1 divided by R3 minus R2, where R1, it is the reading of traveling microscope when focused on ink mark. So here you can see. So this is a traveling microscope. So this traveling microscope will focus on this ink mark. So here I have made ink mark at the bottom of this traveling microscope. So through this microscope we will see the image of this ink mark clearly. So at what reading, see, so here there are two scales in the traveling microscope. This is a mean scale, it is this one horizontal mean scale, this is horizontal vernier scale. So when we move this traveling microscope right and left side, so we have to see the reading in this scale. So here what we are doing, we are fixing this traveling microscope at a particular position. So we are moving this traveling microscope up and down. So for that reason, so here in vertical way also they have given a mean scale and vernier scale. So after adjusting traveling microscope to see the clear image, so corresponding main scale reading and vernier scale reading we will note down. So that will be your R1. Okay. Next. So in this formula R2 they have given. So what is this R2? R2, it is a reading of traveling microscope when focus on ink mark through the glass slab. See, so next step what we will do, so we will keep this glass slab. Okay, after adjusting this traveling microscope on ink mark, so don't disturb it. So just keep glass slab and then try to see the image of ink through the glass slab. So this time we will observe after keeping this glass slab, you will observe. So the image of the ink mark, it will appears blur. So to get magnified image of that ink mark through the glass slab, so this knob we have to use. So here they have given this knob. So this knob we have to rotate in an anti-clockwise. So after that what happens, this traveling microscope will move up and down. So at a particular position, means at a particular reading on mean scale, so again you will get a clear image of ink mark through the glass slab. So that will be your R2 it is. Okay. Then next R3 is what? So after taking R2 reading, means after seeing the clear image of ink mark through the glass slab, after that what we have to do, don't disturb it, just put the chalk dust on the glass slab like a thin layer. So how much dust we have to put on this glass slab? So it should form a thick layer of dust. Okay, like this we have to spread the chalk dust on the glass slab. Okay, so after that what happens, so this time you won't get the image of ink mark. So this time what we have to see, we have to see clear images of dust particles through the glass through the microscope. So for that again what we have to do, we have to rotate this knob in anti-clockwise, so until you should get sharp image of dust particle. So when you get the sharp image of dust particles, so that time whatever reading you are getting in a mean scale as well as in a vernier scale, that will be your R3. Okay, so here, so it is clear R1 is what, R2 is what, R3 was. Okay. Now the question is R, how we can calculate it. So for that they have given second formula. Reading of triangular microscope is equal to R is equal to, that means R, this common formula we are using for to calculating R1, R2 and R3. So this MSR means main scale reading, CVD means cone side division, and CL means LC means least count of this triangular microscope. So this formula we have used. See, so this is the image of, this is the diagram of triangular ray diagram they have given. This is the ray diagram of triangular microscope. Okay, so here at the, so this is a glass slab, this is a triangular microscope, so which we have kept it at the base of the triangular microscope, base stand of the triangular microscope. Okay, next, before going to take the readings, before going to start this experiment, first we have to find the least count of this experiment. Okay, how we can find that least count? See, pause ಮಾಡಿ. So first we will see how to calculate the least count of this triangular microscope. So in the observation you can see, see first point they have given in observation, value of 1 MSD. Okay, see, you can see, so this is mean scale. So you can see, after focusing you can see, so from 0 to 1 just we have to see how many lines are there. So you will see 20 lines from 0